Hello, welcome to a new video. Today, we're going to do this problem called 347 top K frequent elements, and today I'm using my actual computer. As you can tell by the better microphone that I just bought recently for vocal stuff, and with this webcam that is okay, bought it for like 10 bucks, and by this new monitor and my new background. So pretty cool. Today, yes, I said it, this is a medium problem that we're going to do. And then we're going to use this, we're going to solve this problem using my solving process. Yeah. So again, in my solving process, I like to explore the problem. So I like to read out the problem a couple times to get into input and output. Then once I get into input and output, I can go through some examples to showcase my understandings. And I can also ask some questions if I have any concerns about the problem. Then once I fully understand the problem, I like to go over some approaches we can do to solve this problem that come from the top of my head. And then once we find a good approach with that is optimized, um, we can plan that approach and then implement it and then review its time complexities of it if needed, right? Or what we always do. So yeah, so let's get started. So, oh, there you go. All right, so I have more space now. So what we're going to do first is we're going to read over this problem, and then I'll get the input and output from it, right? So given an integer array nums and an integer k, so we have two inputs. Return k, the most frequent elements. You may return the answer in any order, okay? So let me read that again at the same time do my input and output. So the input we're going to have is we're going to have two. So we're going to have an int array named nums and then an int named k. Okay. And then we're supposed to, for output, we're supposed to return k most frequent elements in nums, I guess. And then, okay, so for some questions I would like to ask is, um, even though it's given here that we can see that the output, right? So there's k is equal to 2. So we output the two most frequent. I'm gonna ask just like a question, right? So notes as a question. So my question will be, um, can we return the k most frequent elements as a list, right? And then they'll be like, sure, right? And then another question as I can ask is, does it matter if it's in order? And they'll be like, no, because I'm pretty sure they won't say this. You may return the answer in any order. They won't say this. I'm pretty sure when you're in an actual interview, they make it most vague as possible in order for you to ask a question to the interviewer. So you guys can do like teamwork, right? So they're gonna say, given an integer array nums and an integer k, return the k most frequent elements, right? That's gonna be very vague, and they're not gonna say this. So it's good to ask these questions, right? Or maybe like I remember in an interview that I had before, they showed like some LeetCode stuff where they have an example in the output and input. Some interviews are like that too, but preparing for the worst, which you should always be, is to ask questions, right? So anyways, so I ask those questions and then these are the answers, um, as given here, right? And here. So now that we know the input and output, let's go through some quick examples. Let me just type out of that. So example 1. So let's say our input, right? So for our input, it is an integer array nums and an integer named k, right? So our input's going to be an array of 1, 2. Oh yeah, also I should also ask this question, right? Um, so what if there's no most frequent? What if all the same frequency, right? What should I do about that, right? And I'm pretty sure, um, I don't know what they would say, but according to the code, it would say it is guaranteed that answer is unique. So there is, so they would say there always is a right answer. So basically, an input like this wouldn't work at all. This would be kind of ignored, I guess. So I guess a good example would be to have a frequent element at all times. So our inputs is 2, and then, ooh, that's a good question. Okay, so what if there's a frequent? Okay, so What if frequent, but hmm. Hmm. That is a good question. I don't know the answer to that. It doesn't say here. But I think this is a clue. Like there's always be a frequent. And what if frequent, but not enough for k, right? I'm gonna say I don't know about that, but we're going to just ignore those cases right now and say that there will always be a frequent for amount of k, right? Most frequent for the amount of k. So let's just say that k is equal to 1, right? So as we go through the list, let's go keep track of it in our own brain, right? So we have 1, which appears 1 time, then 2, 2, so 2 appears 2 times, then 3, which appears 1 time. So out of all this list, when k is equal to 1, we want the first most one one of the most frequent elements in a list. And so 1 appears once, 2 appears 2 times, 3 appears 1 time. So the most frequent is 2. So it's going to output 2 into a list, right? So let's do another example. Let's say example 2, with the input kind of similar to that. Will be 1, 1, 1, 1, 2, 2, 2, 2, and then 3. Okay, and k is equal to 1. So we still want the most frequent, the first most frequent. So we're going to go through this list. 1 appears 3 times, 2 appears 4 times, 3 appears 1 time. So of all of that, it's going to be output 2. But what if we have another example, but the list is the same exact thing, but k is equal to 2, right? What would we do? So when k is equal to 2, we're saying to the computer that we wanted to find the first 2 most frequent in no matter what order. As we said here, no matter if it's in order, it says no, so it could be 2, 1, or 1, 2. We already know that 1 appears 3 times and 2 appears 4 times, and 3 appears 1 time, so there's no way that 3 is going to be the most frequent since 2 and 1 have more occurrences of them. So what we're going to do is we're going to output 1, 2, or we can say or 2, 1, doesn't really matter. Pick your poison, right? So we kind of already went through some examples that showcase our understanding of the problem. So now that we're done with that, let's go ahead and get some approaches in order to help us solve this problem, right? So one thing I like to do, I would like to get like maybe like an O of n time complexity, and then O of n space complexity. Let me pause. I need to get some water. All right, so I got my water. So let's see what O of n time complexity and space complexities we can do. So one thing that comes to mind is that we can so we can use dictionaries or hash map. So dictionary, hash map, and counter collection from Python collections. And then we can, with these, we can go through a for loop to iterate through nums, and then keep track of occurrences in O1 lookup stuff, such as the dictionary, hash map, and counter. And then another thing we can do is other than that, we can do just a list to store occurrences. Then just for loop iterate store number print number of occurrences for nums, elements in nums, and then we can do like get most frequent somehow by another for loop, I guess. And then with here, we can maybe call some methods of data structure to get most frequent of k, most k frequent. So those are our approaches that come up from the top of my head. So these are only ones. I believe that the one where we use dictionaries, hash maps, and counters is the best one. It's more method calling than it is just iterating. So let's do that, right? So let's make a plan for that. I'm going to start this one because that's the one we're going to do. So let's make a plan for that. So with the hash map dictionary counter, I want to use counter, but before we do that, I want to get user input of nums and k. I can do that by saying by saying user user num is equal to a list of inputs, and then user k is equal to int input, right? Something like that. And then once we get user input, let's go import collections from collection import counter. Then what we can do is we can create a counter object of nums, and then so we can say that by doing this, uh, num counter is equal to counter of like nums, I guess, and then we can get use method to get top k occurrences and counter num counter. I forgot the method, but it's like something like num counter top or something. I don't know that top. I don't know, something like that. I can just search it up. Why not, right? I feel like in an interview that would be okay, because you shouldn't be able to memorize everything in an interview. So it shows that you're human. I hopefully you weren't able to hear that, but that's fine if you do. So let's go do my plan, right? This seems pretty simple. Seems like a little piece of code, which it is, I believe. So let's do that. So for my plan, before that, I'm going to create a main for driver code. Then we'll run our driver code in the file itself. Then I'm going to create a function called get top k. It's going to take in two arguments, which again is the input nums and k. Nums and k is our input. I'm going to pass it for now, so it looks nice. No red lines under it. So the first part of my plan is to get user input of nums and k. So user nums is equal to empty list. And that list, we're going to get the user input and split that user input into an array itself. And for elements in the the split input, we're going to turn those elements into integers and then put it in this list called user nums. So basically it, and then we're gonna get user k is equal to just integer input. Now we have this. We're going to get our input. Let's go ahead and call get top k with the arguments that we get as input, which is user nums and user k. Then I'm going to, since I know that get top k is going to return the top k occurrences, we're going to just print out its return value, which should be a list of integers. All right. So now, second step is to import counter. That is a library thingy in Python. So we can say, so from collections, is it lowercase? Yes, it is. From collections, import counter, capital. Yep, counter. And then with counter, what it does is it basically is a dictionary, but it counts stuff for you. So you don't have to go through a for loop to increment +1 every time there's occurrence of some sort of elements in the list that you're going through. So I can just say nums counter as in the plan, nums counter is equal to counter, and we're going to count stuff within nums. And so once we have that, it has all the occurrences. So basically, if we have this input of nums is equal to this, it would say, okay, so at the key of 2, we have 2 occurrences. At the key of 1, we have 1 occurrence. We have at the key of 3, we have 1 occurrence. So that's how it's gonna look like. But one thing that I don't know how to do is to get the top 4. I remember I was able to do this last time. So how to get top occurrences in counters Python. Let's see. Max first key count. I'm not sure that's what I'm looking for. Okay, so let's see. It's in this documentation somewhere. So most common n. So most common n returns a list of the n most common elements and their counts from the most common to the least common. So okay, so what we can say is find the most the most k common. So this returns a list of tuple. So what we can do, let me think. What can we do? The most common. So I think it's okay. If we have like most common and then it returns a list of a list of tuples. So what we're going to need to do is iterate through each tuple in the list and then get its occurrences. So I'm gonna copy paste this here. Actually, I'm gonna do this here. So what we're going to do is we're going to call list occurrences, I guess, is equal to counter, no, is equal to nums counter. And then we want to get the k top, k most. We're gonna say most common of k. This will return a list of tuples. But what we have to do is you have to say what is it called? This non-filtered occurrences. And then we're going to have the variable called filtered occurrences, where it basically filters our list, because this non-filter is a list of tuples, so we're going to filter them out so they're just integers, right? So what I'm gonna do is I'm gonna go back to my plan and I'm gonna say iterate through list of tuples, and I want to basically so like for tuple and in occurrences in list, the for tuple and list, I'm going to get what you call it? I'm going to get the occurrence. No, I'm going to get. I don't want it to get the amount of occurrence. I want to get the key, basically. Get the key and append um it into filtered occurrences. Right. That's what I want to do. So that's what I'm gonna do. So for tuple and non-filtered occurrences, it should be uppercase O. Change that. It bothers me. For tuple and non-filtered occurrences, we're going to get its element. So we're going to append. So filtered. Oh, the list should be in here. We're going to append. So filtered occurrences. We're going to dot append the tuple at should be index 0, right? And then I believe the 0th index in the tuple is going to be the key that we want it to be, which is the number in this case within our counter object. So it makes sense because we want to return the k most elements, and here we just return the key of it. In this example, the key value pair would be 1 1, 2 2, and then 3 1, and we want to get the key. So at this point, it will be 2 1. I mean 2 2 and stuff like that. So that's okay. I'm not sure what the time complexity of most elements is. Most common. I'm not sure. I'm pretty sure that's O. It has to be O of n. There's no way it's not O of n, right? But I'll look it up later. But I'm pretty sure it's O of n. Hopefully, right? Hopefully it's not that harsh, right? So now that we have this, if all is correct, then we are going to return a list of integers that represent the top k most frequent elements within the array nums. Let's go run this. Let's go give it a case. Oops. How did I run this? I never actually ran a file on this before. Okay, so it should work now. Okay, so let's say what the example. Let's say we have 1, 2, 2, 3, and then k is equal to 1. Brings us 2. Okay, so that works. What about this? Where we say we have an array of nums of 3 1s and then 4, and then 4 2s, 3 4, and then 1 3. And k is equal to 1. So still 2. What about the same list? So 3 1s, 4 2s, 1 3, and then k is equal to 2. 2 and 1. And again, it said that we can return it in any order. So this works. It won't work. I'm not going to test like edge cases like that. But yeah, I think it should be fine. This does work. I believe it should work. What I'm going to do is I'm going to run it through LeetCode to see if it actually does work. Before I go over its time complexities, because it should work. If not, then flop, right? I believe it should flop. And I need to import collections from counter. Import from collections, import counter. So let me do that. Boom. And let me see if all the variables are correct. So we have nums, then k. That's good looking. We're returning a list of nums, list of integers. Let's do that. So run. And it works on these 2 cases, but let's see if it works on all the cases that LeetCode is trying to give us. And it works. Cool. Oh, wow. It beats 93% in time and 88.22% in memory. Looking good. Then let me just pause it here and check if there's anything that I missed in the description. Okay, so follow up your algorithm time complexity must be better than O n log n, where n is the size of the array. And let me check if that most common is what the time complexity of that is. All right, so apparently, most common method of counter collections, or collections.counter, is a O n log n time complexity, because it basically sorts. Does a sort and returns the list of counts from starting at index 0 through k, right? Through k minus 1. So yeah, it's kind of cool, I guess. Um, so yeah. So for this solution that I just wrote down, we're definitely using O of n space, O of n plus n, which is not that bad. It just O of n, right? And then we're going to go through for loop that iterates through each key value pair in the non-filtered occurrences, and then we're going to use this O of n log n algorithm called that most common, which basically gives us the top k most common key value pairs, and then yeah. Alright, so in general, O of n log n time complexity in O of n space, and that's about it.